Okay, here we are again. Hello, hello. Alright. Okay, send in your problem requests. Now's the time. Do you know the solution for the USAMTS? Which one? What does the USAMTS mean? The one from last time. No, I don't know the solution. Okay. Wow, I see matrices. It doesn't matter that they're matrices, does it? Okay, I'll try it later. Today is episode 130, Twitch Solves ISL, Season 3. Actually, that's pretty funny. It's like, if you have a group theory problem, but you don't want to use the word group, just make it about matrices instead. Because if it's true for any matrices, it will be true for any finite group. Thank you, Interloop, for the follow. Seems calmer today. Oh. Okay, let's see. Da-da-da. Okay. Okay, what else is there? IMC. Yeah, today's quite calm. Thank you over traditional for the follow. Evan, don't do IMO 6. We did 1, 2, 4, 5, and died on 5. Actually, for that matter, we also did pretty badly on 4. Like, 4 took a lot longer than it really should have. Yeah. Work on it. I've actually seen the Schweitzer one with 100 circles. It's, okay, 3v2. Okay, I guess I'm supposed to put it in. Okay. People who use freaking double dollar signs. Oh my god. Like Bush and Gore. They define a scalene triangle. That's funny. Oh my god. Why do people use double dollar signs? I can't. I really can't. Like, I had some bad habits when I was a kid, but I never had double dollar signs as one of them. No, you can still send requests. We'll wait a little bit longer. Very simple and easy geometry. Is this a meme? Why is this statement so long and... Okay, well... I suspect it's a meme, but I'll put it in. Okay, you know, we're gonna make this small because I think it's overflowing the screen. ELMO shortlist 2023 G1. Is that not in my system? It might not be. This is why I need to... Whatever. Oh my god. How many are we at? They're at like 9. IMO 1980 problem 6. Which one is that? I don't even remember. Wait, that's so funny. Oh, I gotta add that to like Anti or something. Oh, that's great. Let me make a note now, actually. Task app, Otis, IMO 1986 is funny. Alright, we'll earmark that, and then... Oh wait, it's a problem request. Shit. See, the problem is that, like, if you give me the AOPS link and I open it, I'm gonna spoil myself, like, right away, right? Yeah, well, because the problem is that... oh no, shit. Actually, I guess... Eh. Crap. Yeah, no. I actually, for this problem, there's not too much you can do. I'm sorry, I didn't realize it was a problem request because I was reading the chat first. Crap. Oh no, someone put the problem and then someone else requested. Okay, I see. Well, L. Replacement IMO. So there were certain replacement events that happened, and what is Romo 3? It's so hard to find. Anyways, yeah, I need to shrink some fonts. We're gonna shrink the essay into script size, okay? Script size. And we're gonna shrink the IMO 6 a little bit. Well, I need to shrink IMO 2023. Okay, thank you, Yofo, for the follow. What is ELMO 2022? Oh god. Oh, there's so many requests. I cannot keep up. Yeah, this is Beamer. We tried problem 5 last stream. It was a disaster. Yeah, I refunded it. Crap. What is what? I don't really want to do. No. Okay. Help. Cannot keep up. Okay. So ELMO 2022-6 is. Oh no, it's an FE. I'll put in the ELMO 6, okay? I'm not gonna put in the ELMO one. There are like multiple people. What is with people using double dollars? More Elven than group, because Romo is like, I don't know. Okay, I'm gonna squeeze in a 10th problem and then we're gonna be done. Okay, alright, okay. Alright. Vote. Okay, so US English grid, linguistics problem, IMC, Schweitzer. I think 10 is actually the max that the poll supports, so this is fine. And then can I re-request something else? Didn't I? Or okay. Oh god. What do I want to do? Is the IMO 3 good? I feel like I don't know how I feel about this statement, but it seems like IMO 3 is decent. IMO 6 is amazing. Well, we'll start with the IMC problem, I guess, and then after that... It sounds like people want me to try the 6. I might just do the 3 as well. Yeah, well, we'll do something. It's fine. Okay, is that Gaokao? Maybe, I would believe that. Okay, let's start with the IMC problem. Okay. Um, welcome back. So, from a college competition, we have three n by n matrices which are idempotent and satisfy b cubed equals abc plus 2. And you want to show a to the 6 is 1. Apparently. Okay. So that is a thing that can happen. So I guess like the first thing is that oh crap. Green screens are struggles. The matrices doesn't actually matter, right? Because if it's true for it should be augmented. IMC is the is like international math competition. I think it's like a college competition. I forget exactly. I've never done it, so I don't know that much more about it. But it should be augmented because if it's true for n by n matrices, then it should be true for any abelian group satisfying the same identities. And if you write it that way, it's like, you know, there's no reason you would want to work with matrices in particular. So like, yeah. Yeah, so it should be like some sort of alg thing, but then what? Well, okay, a to the 6 is equal to b to the 6, right? So a to the 6. See, I'm not even going to pretend they're matrices. Let's like work. Oh, okay, we'll just use capital letters. That's fine. A to the 6 equals to b to the 6, which is like equal to abc plus 2 squared. Sorry, I lied a bit about the group thing. I meant to say algebra. It's like the algebra of... Wait, okay, actually now I'm confused. Is that thing I said about the group true? Is it like... So I feel like the multiplication can be whatever it wants, maybe? But this has two operations, so... Sorry, I might have lied about the thing about being augmented. I might actually need the linear algebra. But also like ABC plus 2. What is the ABC plus 2? So, like, group is a little bit of a misnomer because there's like both a multiplication and an addition. So it's like you're working in some generic algebra, I think. So like some C algebra. Yeah, I still don't really like the eigen thing because I feel like if n is large enough, you can make the multiplication table. Like, if it's true for... It'll be true for C adjoint G for any group G if it's true for the matrices. I guess is what I'm trying to say. And so that makes me feel like I don't really want to touch the eigen things because I can't promise that ABC are diagonalizable at the same time. But on the other hand, like... I don't know. It's weird because ABC don't do anything besides exist. A to the 6. Like, I don't know. Like, I can write dumb stuff like AB cubed C. Cayley's theorem is, yeah. B to the 5th plus 2AC. So like b to the 5c is like yeah, I wonder if the strategy is to just try to get it to be a polynomial in B. A, B to the 5th C. B to the 5th is 2. Sorry, that's a mistake, I think. I left out the B, 5C. So if I think B is wow, this is weird. A squared B cubed C squared. Did I mess up? A squared. Yeah, sorry, you're right. It should be A squared B C squared, which is then which is B to the 5. So if I like fix a matrix B, actually, here's a question: is it obvious that B is even invertible? Because if B is actually invertible is not super. I might actually pull out an alg at some point. Wait, AC equals 0? No way, right? Oh, wait. A squared plus 2AC. Why is A cubed B cubed C equal to A squared B C squared? Okay, cool. I can set squares middle part by doing stuff like ABC cubed. Yeah, that's what I'm doing with the AB cubed C. But I might actually just do linear algebra. 'Cause, like, if you know, the whole point of doing the linear algebra stuff is now you get you turn like matrices into complex numbers. Specifically, like if you fix an eigen vector, you get like it's an eigenvector of c squared. I don't know what to do with the. Where does b to the 5 equals a b to the 5th? B to the 5 is like b cubed times. Where does that come from? How did I get that? Alright, that's a good question. Where did I get that from? Yeah, that probably should be like b to the 7, sorry. I think I was like trying to multiply by like a squared c squared, which is kind of dumb, honestly. I should just. Shows being. Yeah, b to the 7 equals b would suffice if b was invertible. A plus c squared is 0. Oh, that's good. Okay, wait, so what happened? B to the 5 is ABC. I don't understand how this math works. Okay, so the claim is that So b to the fifth is equal to abc b squared plus 2b squared. You move the b squared into c's and then c's into b's. So it's like a b to the cubed c plus 2c squared. Sorry. Wait, isn't it b squared? It's like plus 2b squared, right? And then what do I combine that with? I guess, yeah, okay. The point is that b, okay. So b squared equals c squared. Yeah, fine. Ab cubed c plus 2c squared, which is equal to ab cubed plus 2c times c. Oh, wait. Okay, wait. Yeah, I feel like at this point I'm just wandering in a desert. Plus 2ac plus 2c squared. Okay. Okay, so we actually use the ab cubed c thing. This is like left to right. And then we also do the b to the fifth. So one of them is multiplied by a on the left and c on the right. The other is just multiplied by the square on the thing. ab cubed c. Okay, let me make this self-contained. Okay, so it's like ab cubed c is a abc plus okay, yeah, okay, I'll manip. Yeah, ergo ac plus c squared is 0. Repeat the argument. Also, similarly, a squared plus ac equal... well, actually, if ac plus c squared equals 0, i.e. c squared equals minus ac, then suddenly, like, the multiplication on left and right that we've been doing... Oh, let me just write it out. Similarly, a squared plus ac... Okay, so we now have, by repeating similar arguments, a squared equals b squared equals c squared is specifically equal to minus ac. And if we have that, then suddenly a lot of doors open. So like b cubed was, like b cubed is equal to like minus acb Okay, so yeah, so what was I saying? So like AC times B, like minus ACB is equal to ABC plus 2ID now. And similarly, like b cubed is equal to ba squared minus bac. So we can like deal with a lot of cross terms now, like. Feel like it's important. No, I feel like it should. I don't know. I feel like it might end up just being algmanip only. I'm not totally sure about this, but I feel like because if it's true for matrices, it'll be true for K adjoint G for any group G or something. I'm not sure. Anyways, A is invertible now, because yeah, A is invertible because now we have like A times BC plus CB is -2. How did you get the line with b to the 7? I mean, we're not using it, but it's to multiply by a squared on the left and c squared on the right. And maybe we should use it now that we have... Oh god. Is 2 a primitive root for infinitely many primes? Open. Oh wait, yeah, actually hang on. If A is invertible, then... Actually, a squared plus... Okay, yeah, here invertible, okay? In particular, A is invertible. Consequently... Consequently, A plus C is equal to 0. Okay, wow, this is so weird. So now there's only 2 variables. So we can just do it in terms of A and B. So now we have A squared equals B squared, and B cubed equals minus ABA plus 2 ID. Okay, so now I can square both sides, right? Why are there only 32? 32 is pretty normal, actually, I think. Like, I don't know, math streams are very niche. Audience. Minus ABA, ABA. Okay, so it's like AB to the 4A. Minus 4 ABA, which is like... minus 4 or something? Okay, and ABA to the 4 is actually equal to B to the 6, right? So despite the fact I was trying to get b to the 6, the b to the 6 actually cancels and gives b cubed equals 1, which means I definitely made a sign error somewhere. Because... Okay, well, what did I flip? Minus... Yeah, this is plus. And hence b cubed equals minus id. Can I just not have the id at this point? I'm just gonna leave off the id when I write this up. So b to the 6. Why does a b to the 4a? Because a b to the 4a is equal to a squared, a. Which is equal to a to the 6. Which is equal to b to the 6. Yeah. Yeah, so that happened. I still have no idea what's going on. Like, I feel like I just manipulated some things and it worked. But here we are. Yeah, it has that feeling. Thank you, Blades of Grass. This holds over all matrices. I mean, what do you expect? Like, complex is not used, which is completely understandable. Okay, maybe not F2. Yeah, okay. I agree it might not work over F2, because F2 sucks. Yeah, we did it. Okay. Thank you, team, for helping me with algebra, because I do not like manipulating expressions. Okay, we start with the following claim. Yeah, it's interesting because, like, even for high school Olympiad kids, Olympiad students don't typically work with non-commutative rings, so I don't think it's like not only is it algmanip, but it's the kind of algmanip you're not used to if you're still in high school. Yeah, okay. Yeah, I reconfigured my whole editor like yesterday, if for anyone that was watching. So a bunch of shit isn't working now as usual. Uh, yeah, but here we are. Wait, what? Okay, so I need to deal with that later. We start with the following claim. Actually, let me do it this way. So I ended up not using any of this crap, and we just started with this calculation. Yeah, Como is tough. So following the analogous argument, we now have, actually, yeah. Finishes the claim. And then claim, so then, now notice that, ABC plus 2, now since b cubed equals, how did I get BAC? Sorry, I wrote minus AB when I meant minus AC. Now we have, okay, so notice that this means that minus 2, I'm gonna leave off the IDs because I actually think they are distracting. It's 2AB plus BAC, so C is invertible. Combined with the claim that AC plus C squared equals 0. So actually, I want to, I'm going to squeeze both of these in. Okay, so blah blah blah, and then I know you type at like 300, but I should use ulti snips. Yeah, I may do that at some point. On some recommendation, but I haven't done that yet. Okay, is that it? Okay, sure. Fine. IMC is... Where is it? Yeah, this is... I don't know. Non-commutative algorithm. What a concept. Oh, what the hell is this? AB cubed equals B cubed. Oh, really? Alright, yeah. That's pretty good. It's like AB cubed C and then B cubed. Oh. Did we miss that? Did we have an AB cubed? I don't think I ever did just one side. Okay. Oh, that's pretty good actually. Ah, lame. Okay, yeah, what was next on the list for today? Yeah, true, if they're in AS... Is that how I can sell out to get more viewers? Long Trio was definitely not the night. I think that was like IOL and IMO 6. I was like, do I want to do IMO 3 before I start IMO 6? Okay, first, do I want to fix my configuration files because they're not doing quite what I want? Okay, I think it's just not doing what I wanted to do. I will deal with it at some point. Yeah. Putting this stream in ASMR category is sketch. Yeah, probably. Okay, where were we? So do I... I'm like scared of the IMO 6. Because like people keep telling me it's like super hard. I'm gonna do the IMO... I don't know. So you have to find other streamers. Yeah, well, I don't know. And I think I don't expect this stream to be like particularly big just because like it's not. It's too niche of a topic. Alright, let's just do the IMO 3 first. And hope it doesn't take too long. I mean, kind of got assassinated by IMO 5, so I'm a little apprehensive, but... Tim Gowers. Oh, I didn't know that Tim Gowers has... Oh, Tim Gowers does YouTube. Did not know that. Okay. 8K subscribers. Good, good. Subway Surfer, Family Guy in bottom left. I think I might run into copyright issues with a Family Guy. Yeah. Okay. Let's attempt the IMO 3. We may or may not actually work. What the heck is the statement though? Okay. So, fix K at least 2. We would like AN, okay. What the heck? So first of all, does this even happen? Like... so for K equals 2, can I get a single example of a thing that does this? We want the identity. A sequence of positive integers satisfying an plus 2 times an plus 1 is equal to an times... an squared plus coefficient times an plus coefficient, right? So does this happen? And it's... I mean, okay. Like, the answer is technically yes, because the Fibonacci sequence works, right? Or... How does it go? It's like... 1, 1, 2, 3, 5, 8... I forget how it goes. Sorry, it's not. It's like something about Fibonacci squared plus 1 being nice. Fuck. What was it? Yeah, 5 times 13. Shit. That's actually off by index. That's like an plus 2 an equals an plus 1 all squared plus 1. Okay. Okay. Never mind. But oh, actually, a near linear recurrence will not quite work. Because it grows a little too fast. Right, like if I was trying to get some sort of linear recurrence, then that's not great. On the other hand, if all the AIs are equal, that's also not great. That goes to oh, this is so bad. Wait, actually, no, you can't let them all be equal, right? We could just let. Okay, so there's a dumb example where AN's a constant and CI equals 0 for all I. That is a working instructions. Is the answer just gonna be if the answer is just constant sequences? That's kind of lame though. But yeah, linear recurrences won't work. Wait, also, okay, like, AN equals N? Well, wait, actually, hang on. Wait, can't I just, like, let AN be, like, N, and it also works? Then, like, N plus 1. That is a polynomial in... Wait, okay, now I'm really confused. What the heck is the answer set gonna be? It's like what? Okay. What if I let AN equals N plus 1? It's like... is N plus 2 times N plus 3 a polynomial in... Yeah, I mean... Well... Actually, just if AN is A... Is this true? Yeah, this is true. And like, I can do it with 100 too, right? Like... 101 plus 102... Because I'm just shifting all the indices. Okay... Does any arithmetic progression work? Oh, actually 2 might work. Yeah, the answer could be APs. Cause if I do like... If AN is 2n, then... Like... 2n for... 2n... Hang on. 2n plus 2, 2n plus 4 is equal to... So the question is this like... Well, yeah, I mean, there you go. 2n squared plus 4, 8, 12, 6 times 2n plus 8. Okay, what if an is like 2n minus 1? Does that work? Should be fine, right? So yeah, AP is fine. I don't think you can do little O. I think it's a little sensitive because there's like non-trivial number theoretic information. Actually, little o doesn't make sense because a single AI is enough to kill things, right? Like, if a of 100 is like slightly too big, then it might be prime, and then P of A99 will never work. I think every arithmetic progression just works based on this, and AP should be easy to check. And then it's just a question of like, how do you disprove the other crap? To which probably it's something somewhat asymptotic. So in particular, like, if you do the thing to get rid of, even for n equals 2, this might be worth doing. I'm not sure. But if you look at like an plus 1, an plus 2, an plus 3, like on the one hand, this is equal to P of an times an plus 3, and on the other hand, it's equal to like P of an plus 1 times an plus 2, which is the thing that can happen. For k equals 2, this is actually, try an equals minus n. No, an is explicitly given to be positive. Can we look at the difference? So if like if I look at the sequence where A1 is 2 and everything else is 1, why does that not work? It's like I need it's like weird because like you would think that if you have an entire polynomial, like maybe you can fudge just A1. Because A1 is only read in the problem once. So it feels like there should be like a little bit of flexibility, but apparently there isn't, which is weird. Like in what situations can I not just mutate the value of A1? Like if an equals n, then if an equals n for all n strictly greater than 1, for example, if it's the identity for all n strictly greater than 1, that identifies the polynomial. And then it's like n plus k, and then it's like P of A1 is equal to like 2 times 3, and it's supposed to uniquely, okay. So I guess what I'm getting at is like P injective seems pretty important. As P is injective. Actually, injective is a misnomer. I should just say it's strictly increasing. In particular, injective. Which means that if you get a polynomial-like relationship for... Like, if the ANs are eventually given by a polynomial, then they're actually, like, coincide with that polynomial. So, this suggests... If we know strictly increasing, that suggests that I should be able to try to go backwards in some way. Like, is the problem that bad? I don't know. Okay, anyways, yeah, I don't know. So it's sort of like an plus k is... Yeah, I do like the ratio thing. It's like, so if an plus 3 divided by an plus 2 is like p of an plus 1 divided by p of an, and yeah, I want to do analysis, but I'm not sure exactly how. I think it's true that this implies that like something. What is this doing? Yeah, but I don't like. What does asymptotic mean? Like, you're assuming there is a limit. Like, I agree that if there is a limit, then it equals the thing you said. But I don't know that there is a limit or something. I think. Also, here's the problem with this. Like, I can pick any polynomial p and get a sequence AI that quote-unquote works. Except for the fact that the AI are not integers. Or like, you can imagine... I don't know. Like, I don't know, pick like p of x equals x squared, and then k equals 2. And then like, then a1 is, you set a1 equals 1, and a2 is equal to whatever makes it, like a2 equals like 2 maybe or something. And then a3 is equal to, okay, so a3 is equal to half. or something crappy like that. And then A4 is equal. Yeah, so you could like imagine making a sequence, and like the only issue with this sequence is that you actually need the integer condition, because otherwise you can just do this and then recursively define an plus k equals like the previous crap divided by stuff. Because in general, a sub n plus k will be given by the product of, it's like p of an divided by like the other. So this recursion is determined by picking a1 up to ak and then letting, and it is a recursion, so it will give you like numbers. And the only question is, will those numbers be integers? And yeah, I guess it's like if the AI sequence grows at all, like if a of n is at least, wait a minute, hang on. Shit, sorry, that's a typo. Yeah, like, so I feel like I want to, if there's a repeated AI, like if p of AI equals p of aj, that feels pretty bad. Something's supposed to happen when that happens. Like the sequence being all constant, for example, I think. If there's no repeated AIs, then it is true that a of n is at least like, for some large constant, like sufficiently far off, an will always be at least n. Is that true? If there's no repeats in the sequence, then the AIs get big enough that fuck. It's annoying because sometimes they're in the numerator and sometimes they're in the denominator, and you really want this is like an. Okay, in this example where I did 1 to 1/2, like what is the growth rate? It feels like it keeps, this one will actually jump, it will oscillate, right? That's why I'm so annoyed. It's like a5 is equal to 1/32. Yeah, it's oscillating. So the integer condition is really important. Because otherwise, like, you can come up with arbitrarily dumb sequences that satisfy the condition. Do we actually prove P is strictly increasing? What do you mean, do we prove P is a polynomial with non-negative coefficients and at least one positive coefficient, so it's strictly increasing over positive numbers anyways. I mean, is that for real? Okay. What's happening? I am trying IMO3 and not getting very much. But it's like... integers. I need to use the integer condition. I'm like not really doing it, and that's bad. Anyone feel like the difference of an plus 1 and a... Like, if I look at p of an plus 1 minus p of an, there are a lot of factors, right? Or at least like an plus 2 divides it. For large k, it's like a lot of factors, but I just can't deal with the oscillation. That's the problem. Like if I try to use pure size, I'm gonna die because of this green example. So I need to do something that like... Oscillation? Yeah. Like, if you drop the integer condition, you can get examples that are large and then small. For that matter, like, why is there... So, up until now, I found examples that were APs, like arithmetic progressions, and I wonder if there are examples where, like... It's like 224466 or something like that. Are there examples that look like that? No, they're like, well, no, actually. Once an plus 1 is strictly greater than an, do you get more increase? That's true. So if there's any indices for which, if you take an index for which this ratio is greater than 1, well, no, the problem is that, like, it transfers you to an plus k instead of an. So if an is bigger than an minus 1, then yeah, okay, maybe I should use the strictly increasing distort or something. Like, we can, so at least we have a statement like, if an is bigger than an minus 1, like, an is bigger than an minus 1 if and only if an plus k is bigger than an, or something like that. So if, like, if a2 is bigger than a1, then a4 is bigger than a2. Is that useful? Well, the reason we know it's not number theory is because IMO1 was obviously in the number theory section. So this one is not. Also, the IMO4 was obviously in the algebra section. So we know this came from the algebra section. Yeah, I agree if it's mostly analysis, it's just I need to use the integer condition somewhere. It's possible I only need the integer condition in so much as, like, every AI is at least 1 is a possible use of way to use the integer condition. That's probably not good enough, but... Yeah. So... Why is, like, an equals n squared not a solution? If I do, like, n squared plus n plus 1 times n plus 2... Why is that not never a polynomial in n squared or something? Well, I mean, if a polynomial is... okay. Yeah, fine. Well... Then an plus k is less than an. Oh shit, did I flip the... Oh, that's a good point. Okay. Yeah, it works better the other way. If an is... Okay. Then it's also smaller than an plus k. Yeah, okay, actually... So it's like I should look at the contour or something. Like, look at the shape of... You're right, this is actually like, I don't want to say transitive. But it's like, if A1 is bigger than A2, then... Oh, shit. Okay, so if an is bigger than an minus 1, so if it goes down, then later on then also, the small number also has this thing less than it. So then look at a point where... But these can go back up, right? Like, I just know an plus k is even smaller. But... Oh, but it's smaller than the smaller number. Oh, fuck. Okay, fine. It's smaller than the smaller number, not the one before. Oh, okay, fine. Yeah, sorry. I keep flipping the order, so I got confused. But you are correct. So claim, so either AI is eventually constant. So, well, let me just say. This might like be the only place we use integers, honestly. Then it follows that an plus k is less than or equal to an is even smaller than an, so there is an index L between, like, such that there's another index L such that AL is less than or equal to AL minus 1 for L n plus 1 up to k plus 1. So it's like it went it's like an okay. I need a picture. It's like it eventually goes down, and then it's like AL. It should go down to an AL such that AN plus K. So between AN and AN plus 1, there's a take the lowest, and then there's something less than or equal to it. So if it strictly goes down, then it's equal, and hang on. Okay, yeah, let me do this slowly. Ah, this is so indices. So we get infinite descent. Hence weakly increasing. And then to transfer to strictly increasing, repeat the same argument with an equals an minus 1 implies n plus k equals an, and so on, because we're weakly increasing. It's all good. Okay. Okay, that took way too long. Oh my god. It's smaller than the smaller number. It's not what I'm used to. It's, yeah, it's because we used the AN. Okay, fine. So if you go down, then the next thing is even downer. Yeah. So in particular, the sequence grows at least as fast as So yeah, I feel like that bounds the growth of AN plus K by a lot. Because now your sequence actually... Okay, this feels a lot better for asymptotic crap now. Okay, I should be careful and write, unless it's constant. Okay, so where were we? So here's the problem again. We know it's increasing, and we also have the recursion. So assume A1 is less than A2, less than so on. And we have this relation. And what I want to show is that AN plus K is bounded by, like, something pretty reasonably small. Like, in particular, I really want it to be linear. Why did I say that n squared didn't work? N squared didn't work because, like, well, who knows? Yeah, PA of n is greater than AN to the K, so... P of AN is at least... Are you trying to lower bound it? I mean, we can do that. I was trying to upper bound it. Like I want an plus k to grow like slower than things. Actually, for that matter, if I just take the like difference between these two, like like something like this. Like, I don't know. It's just not gonna grow very fast. Like, I feel like I want to do some finite difference type argument now, where, well, finite difference I'm only need to do it like a couple times. But like the idea is like an and a minus 1, like this difference shouldn't grow particularly fast. Because it's like, right, because this bound here, yeah, I'm so glad I have the strictly decreasing now. Holy crap, that was like being so annoying for so long. Like we can bound this by but I don't want to bound them by. So I take the difference sequence, like the sequence of the differences between them, and then like p of so I know the answers. I suspect the answers are arithmetic progressions. If I take I don't know. I'm looking at like suppose I have this interval from an to an plus k, and there's like a bunch of differences. Okay, and like this is the product of yeah, an is bigger than an minus 1. So this feels really. Can I look at consecutive differences? I'm gonna look at three things. I wanna show like the differences. Also, don't behave badly or something. So let me actually write down three consecutive indices. It's like an plus 1, an plus k. Yeah, it's definitely O of n. Like this alone is already like I don't know. I feel like I'm running into like a same version of the issue before. Like earlier before I was like, you know, if it's monotonic, we're fine, but it's not. But it might not be, so I had to do this thing with like the integer condition to like pin it exactly. And I want to do something like kind of similar here where like, you know, if the growth rate is actually it's like one more step where I'm using the differences instead of whatever they're called. Anyways, like it would be really nice if like a list, like if a one difference was bigger than the next one, it transferred to like some other difference later being yeah. Yeah, I mean, what you can say here is that this is less than or equal to p of an times an plus 1, an plus 2, an plus k minus 1. So this is like less than or equal to an to the k plus like some constant an to the k minus 1. And then some crap in the bottom. So there's some constant depending only on p, not on the an, such that this is true. And so then when you do the division out, it's like an plus more constant. It's like c equals k minus 1 factorial or something like that. And then yeah, there's some constant c, which is fine. And then it's like some c prime. Yeah, so a sub n is sublinear, which is good. And I guess if we're working with integers, then you can actually do some combo where you say like, if you look at k consecutive differences or something like that. Well, actually, it's just sublinear, period. So eventually certain difference patterns have to repeat. I don't know if that's exactly how I want to go about this, but it's seems pretty good. I wonder actually if I could just bound the rest of it. Like, I don't know. Because I guess the reason like, if a sub n equals n squared-ish, that doesn't actually fail for size-ish reasons, right? No, wait. What am I talking about? I'm high. N squared is not sublinear. Actually, yeah, we can. Okay, I'm gonna try the dumb pigeonhole thing. All right. So because a sub n is sublinear, for any k, there's a pattern. There's a sequence d1, d2, dk of differences, such that for infinitely many indices n, we have a sub n equals a sub n. And this is because the di's are bounded. Okay. This feels so icky. This is such an Olympiad argument. Oh my god. So there's infinitely many indices n such that this works. And for all those indices n, we have p of a sub n is equal to a sub n plus d1, a sub n plus d2, a sub n plus dk. So p is actually exactly given by this polynomial. Oh my god, that's such an Olympiad argument. That's totally the kind of thing we do in high school, isn't it? Okay, so p is actually given exactly by this polynomial, and if that's true, then for every shit, sorry, I misspoke. It's like d1 plus d. Actually, you know what? We'll just, we don't need to nest the differences. We'll just do all of them by n. So there's a sequence of di such that this works. And if that's true, then starting from any index, I should be able to backwards propagate, or something like that. I don't know. Or I can do number theory. That is also an option. Aren't you just done now? Explain why I'm done. Why am I done? It helps a lot though that we know it's yeah. I agree that it seems like we should be almost there. Like I think after this, like now that we know P so exactly, we should kind of just be able to run it over. Um, I almost want to do a bit of number theory now because if we know that how this thing more or less factors, but it's not quite there. I agree that yeah, I agree that differences should all be the same. You can bound the GCD. Okay, let's write this out. So now we have an plus 1, an plus 2. For all n. The GCDs of any two terms on the right hand side divide some absolute constant. Not absolute constant, just some constant. D is product di. So if an is big enough, then because the things are all so close to each other, you cannot redistribute any prime factors, is the claim. Because if you tweak by a prime factor, you're multiplying by some scalar. When n is sufficiently large, no number of the form q times an plus di where all primes, see, this is number theory, all primes dividing either the numerator or denominator q will still lie in the interval an plus c prime. Right, so c is a constant, an is really big, and I can only... You have big numbers, and then like... the difference is at least... So that an is bigger than like c prime times... c prime plus like 1 over d. I think is the threshold. Sorry, not c prime plus 1 over d. C prime times d. Wait, shit, no, this doesn't... Am I high? I think I might be high. What am I doing? Sorry, I think I'm stupid. This doesn't work. This doesn't work. Sorry, no. Ignore everything I said. Yeah, this doesn't make any sense. I don't know what I'm writing. Yeah, we would like an plus I to be equal an plus d sub I. Well, if I show it, yeah. I would like them to be the same set, yes. I agree with that. Only one list of differences appears infinitely often. Oh. And everything else happens finding. Oh. Good point. Oh yeah. Suppose a sequence of it appears for randomly in the NPS, and so in particular, only one sequence of DI appears infinitely often. Thank you, Warren. Yeah, okay. Yeah, so hence, for large enough n, we're fine. Yeah, this gives you periodic. Not only is it periodic, it's periodic with period 1. Yeah, it's not even DI periodic. It's DI is periodic with period 1. Or not periodic's not the right word. Actually, well, sorry. It's more confusing if I write it this way. Now that we're doing, sorry. We're gonna make it the actual differences, okay? D2 plus D1. Yeah, we're fine. We're good. This will do it. Plus D, K. K minus, hang on. Yeah, DK. There's a coefficient bash? Ha, sucks to suck. Yeah. Just, only one sequence appears for the object. Okay, we're done, right? Okay, this problem's not that empty. I think it's like, I don't know. I think it's not supposed to be a number theory problem and you can tell. Like, I don't think it counts as anti if... Okay. Anyways. Okay, that happened. So, yeah, I think we conclude that IMO 3 is easier than IMO 5. Which is, we kind of knew already, but, okay, first things first. We need to fix the LaTeX. Okay, wait, I don't remember the... I have a new toy, so I'm, like, learning how to use it. Begin. So M is for frame. Okay. Okay, R is frame. Got it. Fake latex. I mean, so I think the I don't know. I don't know how long it would have taken me to notice. I think I would have gotten the increasing eventually because I had the direction flipped in my head, so I thought it didn't work. I might if I was. I don't know how long it would have taken me to notice the only one difference appears infinitely often thing. I don't know. There's like a few steps, so it's like if you miss any of them, you're just kind of sad. Yeah, okay, let's write this up well. So the answer is whenever an... It is arithmetic progressions, right? Indeed, if an is equal to kn plus l, or I shouldn't use k. Fuck, I don't want to do the check. Can I just... Oh, actually, it's obvious. Never mind. If an is the n plus e for n, I was about to like manually expand. Then an plus 1. Let's take p of x equals... Okay, so first thing, claim either... Oh shit. Either A1 less than A2 less than da-da-dun, or AI, the sequence is constant. Okay, so note that polynomial p is strictly increasing over n. It follows that... Now, first we show... So assume for contradiction there's some index n such that an is bigger than an plus 1. Then an plus k is bigger than an... Oh, sorry. So there must be some... Let L be the smallest index argmin so be the index minimizing an AL. Now AL is less than or equal to... Okay, so then okay, so now similarly, if there's hence we have a1 less than or equal to a2. Da, da, da. Thank you, Lunson AM, for the follow. It is constant. It is fully constant. Okay, cool, cool, cool. All right, and so now for the crux move, the big step was where he's like, okay, for each index n, we can consider the associated differences. Or no, actually, we have to bound it first. You have to bound it first. So claim an there exists a constant c such that depending only on k and p, actually, so okay, let c prime be a constant such that p of x is less than x to the k plus c prime of x for all x in n. Let's just do it that way. Okay, that works, right? It's actually the actual constant is like k choose 2. It's like a to the k plus did I get that right? No, actually the constant is on the bottom. It's like, wait. Oh, I suck at long division, sorry. No, it's on the top. Wait, hang on. Yeah, wait, there's no kitchen. It's literally. We can consider the associated differences d1. Consider the associated differences d1 equals an minus dn equals an plus k minus. Yeah, so we're being a little wasteful, which is normal. 2017 N4, is that the... Yeah. Yeah, that problem is... That problem is like a tutorial problem. Like, you do it so that you learn the concepts, but you wouldn't want it to be like the main show. Then d1, dk can only take up to c to the k value to... In particular, some tuple must appear only infinitely often. For that tuple, we obtain for infinitely many n. But because of that, we obtain... So we actually must have which we denote by delta n. There's also at most one that exactly one output to delta occurs infinitely often, because that output is determined completely by p. So consequently, follows that delta is eventually constant. For this to happen, an must eventually coincide with an arithmetic progression of some common difference. How do I know C exists? Because P of n is given... Oh, sorry, it should be x to the k minus 1, not... For example, C equals C0 plus C1 plus Ck minus 1 plus 1 will work. And P of x is equal to x plus dx plus 2d, I plus kd. Finally, this implies my downwards induction that an ta-da! All right. My jump is broken. Okay, I gotta deal with that later. Um. Analysis, manip, size. I think this is reasonable. Oh. Good or nice? I'll classify as good. Find. Actually, it's not really manip. Okay, here's the URL. Okay, now for the part where I give a hardness rating. No, we're not putting it at 5. I'm wavering between like... I haven't decided for IMO 5, and I don't know if I can because I eventually died on it and had to read the solution. I think IMO 5 will be probably at least like 35, if not 40. And this feels easier to me than that. 25? 25 seems a little... I'm gonna go 30 for now. We might change it later. I'm gonna tentatively pencil in 30. I feel like there are kind of a few steps. Like, each individual step is not earth-shattering. Like, each individual step is like quite expected, but you do have to get them all. Like, you can't miss any of the inner. Or you can, but maybe you have to work a bit harder. Yeah, honestly, 50. I don't know if P5 is 50 because everyone on the US team, I think except one person got it. But it's high. I think 5 is quite tricky. Oh, yeah, P4 I don't think is 15. I think P4 I was... I convinced myself that I needed to do something that I didn't need to do. I think problem 4 you will... If you have enough... I think if you're very well trained, you will eventually solve problem 4. Like, it's just how much stuff do you try that doesn't work before you realize what's going on. But, I don't know. Yeah. This is a good comment. Simo 3. I don't feel like this is... I don't know. It feels a little too involved. It's like, I think it's too many steps to be 25. I agree it's... Yeah, I don't know. Like, I mean, if I didn't have the stream to, like, tell me when I was being dumb, I think it would have taken me a lot longer. So... Mm, I don't know. Honestly, I think if I go to this IMO, I get like 1, 2, 3, 4 or something. I'm assuming I'm not going to get 6 anytime soon. IMO 3 has less solves than 5. I don't know. I just feel like it's such a... I just feel like there's no trick. Like, it's... What you think is going to happen, happens. And you just need to execute it. Like, maybe the most thing that was, like, weird was this, oh, do this infinite pigeonhole on delta. But I think infinite pigeonhole is just, like, such an Olympiad argument. I kept saying, it's like, oh, this is definitely the kind of thing you do in high school. Is like, just say, look, there's a function from an infinite set to a finite set. I think it helps if you know that problem 1 was NT. That does actually seem like a big advantage, is that the fact that problem 1 was on the paper is like, oh, it's definitely not... This came from the algebra section. So you're not going to be doing stuff with, like, random primes. Or whatever. I don't... I think this is, like, the first time that, like... I think seeing the... Like, knowing a bit about how the IMO test is put together actually mattered more than, like, comedic value. Yeah, I mean, it's not like a formal written policy, but it's just like, you would be very surprised if the jury votes to put 2 problems from the same category on the same day. Even though it happened in 2014, so rip me. God, I didn't get any number 3 on my IMO. It was really sad. General only slang? I don't... Do I want more slang in this world? Yeah, 2014 was, like, problem 6 was combo, and then problem 5 was N3 in quotes, and it was the Bank of Cape Town. So, number theory, because it had 1 over N in it. And... yeah, but, anyways. Okay, so... Okay, we did that. Okay, is this long geo really super... I'm so confused why this long geo is like a meme at this point. Long geo is 40 to 50. Oh god, do I want to do a geo with that? Well, the problem is the alternative is IMO 6. Oh, well, okay, the actual alternative is the linguistics, because that also had 4 votes. I don't know. No, I'm gonna look at 6 eventually because everyone's telling me it's amazing. I just like don't know. Is it worth doing on stream? Because if like it's just like 2 hours. If it's like if it goes worse than IMO 5, then it's kind of like a waste of stream time. I think because it like watching. Well, okay, the IMO 5 was like at least a little entertaining because like you could watch me like attempt to do induction and fail in like 7 different ways, and uh, what's the term? Schadenfreude or something like that. Yeah, but if it's just like an hour of me like looking at the problem and being like, what the heck do I do? I don't know. I think it's like pretty bad for entertainment. Schadenfreude. Here, I found it. There. Oh, Hang's got it exactly. Yeah, apparently this is
Schadenfreude.
Schadenfreude? Okay, I was not even close. There were a lot of other things. The one I'm looking at is like the emoji one because it looks like a clean geo. Like clean geo is good because we will usually eventually get it. There's also ELMO 2022-6, which is an FE. What is 23X? Oh. Let's see. Okay, let's do the linguistics. It did win the vote, so I will. Oh no. Since it's only a P4, I don't think that's how Schweitzer works. I think Schweitzer is just like 1 through n for some n. It's not a IMO format contest. Okay. Alright, I'm gonna set up a linguistics board, which could take a while because this always takes a bit. What the heck? I don't know how to use technology. Okay. And I need to copy in the ILL. Why is it so dark? What percent of Exeter Otis goes to Exeter and over TJ? I don't think it's that many, honestly. Okay, actually, I wonder if desktop view is just better for this, because we're going to be... Okay, cool. All right. Welcome back to... Oh my freaking... Wait. Wait, you're kidding me. There's just not English? Are you serious? Okay. Well, we have linguistics. Yeah, and there's no English. Usually it's like... Wait, did I fail to copy the statements of what I'm supposed to do? Oh, I think I failed to copy the problem statements. Let me put that in. No, no! I want to paste it somewhere new. There. Alright, cool. Yeah, so, yeah, Nagambia's 2 was... Alright, sorry, Yamparo better be 2, unless Nagambia is 0, in which case I'm gonna be really mad. But I don't... That would be too mean, I think. Is this gonna be a base 10 system? Like... Okay, anyways. Yunno Taksu... Yamparo is like 2. So it's like... Yeah, unfortunately, equation 7 gives no information about, stuff. Nagambi. Nagambi can be anything, even 0. Okay, what's about the stuff on top? Oh my lord. Yeah, Nimbo seems like 10 in their base. See, the one that really bothers me is this thing. Like, it looks like I'm hoping that everything's positive, but like 50 SR Taxual looks like it should be bigger than... I don't know, it looks really long. um... Oh, there's no operations in the, I see. So 13 and 16 don't have math operations in them. So... Sen on, yeah, on, sen. Easy for ILL, but good for stream. Oh my god. That's... This is easy for ILL? Okay. Okay, I'm gonna highlight some crap. Like this this string appears a lot. So Asar appears in like 2 places. Then Chen Son Tonli Ton Tonano. Yeah, I'm assuming the bases are different. Nimbo plus Yamparo. So we know Yonparo is 2 specifically. Yeah, Yanbaro, Taxo, so like... I don't know, like... This one is like, whatever the base is? Or something. It's like, says... If we believe this is some sort of base system, the fact that these 2 are still the same, like the Taxo is the same, means like Nimbo's probably the base. Does Nimbo appear anywhere else? Nimbo... Fete means party in French. Okay, I'm gonna... God. Actually, wait, there's a bunch of Taxos. I'm not paying attention. Taxo. So, if I believe the theory about a base, Yanoa is like... Wait, there's actually a lot of text rows. Like, what kind of digits would satisfy this? Like 50 is an actual number. Like, okay, if I think this is... Oh wait, sorry. This is in the, yeah. Nimbo shows up twice. If I believe that there's a base happening, then has to be like, if it's base 10, 20, either way, Yanoa is like, it should be co-prime to the base in order for equation 10 to possibly be true. Just try stuff. Yeah, the very legit strategy of randomly guess. All right, sounds good. Like, if YT is T, like, if Yanoa times taxable is taxable, then, like, y minus 1 times... Like, if I believe this is... Like, if this is base 10, for example, then taxable has to be something like 5, right? And then, like... Or 5 times... Hang on. Okay, let me learn how mods work. If this was base 10, then it's like YT is T mod 10. So 10 divides Y times T minus 1. Which means I want... This would be like 6 and then... Hang on, wait, why do I not know how to use mods? What the heck? YT equals... Oh shit, I factored wrong. Can I just pray that these are digits and like pray? Like if I think like this is... It doesn't feel right as... Say it might be 1. Yeah, maybe. 1 feels pretty okay there. Okay, if I believe this is base 10, then 6 times 60 is like 360-ish. 6... Yeah, is there a number for like y plus t sorry, y times 10y plus t is like congruent to 10y plus t mod 100. Is that a thing that can happen? Anyone want to solve a mod equation for me? uh, it's like y minus 1, 10y plus t has to be divisible by 100. 75, and also can you answer confirm? Is it not on Arch? Yeah, check the 30% hint. It has the answer. Okay, you know what? I'm too bad at arithmetic. Python. For y in range. Oh, y just has to be 1, really? For this to be true? Okay. Actually, that makes a lot of sense. Yeah, actually, that makes a lot of sense. In hindsight. Oh, actually, yeah, that makes a lot of... Wait. But if y is 1, that's... Okay, something's wrong. It's not base. If y is 1, then, like... You know, 1 times 10 plus t is probably not... Okay, so it's not just the base. Oh, damn it. Okay, well, so much for that. Do you still do 1 for 1 for 2048 V-Bucks? Yes. But, not in the middle of a problem at this point, maybe. I don't know. Depends on how annoyed with the problem I am. Wait, what am I supposed to do? Yamparo Fete. Like, I feel like 9 and 10 together, I should be able to, like, do something. But I can't get anything to do what I want. If I believe in some base, the thing is, I don't know what the base is, but like these are also equal. Um, like this is probably either like 5 or 6 or OME. Makweli plus Om is Chicom. Yeah, anyways, yeah, for other reasons, you know, is probably 5 or 6. And I don't know what's going on. Can we just make an assumption and see if it works? We could. If you tell me what to assume, I can try it and see if it works. I just can't. I don't know. Like like my problem is right now, like equation 10 was the one that I was staring at, thinking maybe I can like guess a solution to it. But if it has no solutions mod 10, that makes sense. Or sorry, in base 10. Like it's not just digits in base 10 for some base. Or probably any base, really. Like 50 would have to be like 20 or something, which actually would make sense. Like it could be like Fete Yunoi is like Yunoi is 10 or something. Or no, that's too big though. Like it could be like 50 is like plus 20. That's possible. In which case, I can. So if 50 is plus 20, then this equation is instead says equals 20 plus that. And those will have some pair energy. I don't know. No solutions either. Okay, never mind. Yeah, I guess 20 is too small. Could it be like plus 50? This is so desperate. Oh, motherfuck. Yeah, still yeah, I don't know. Like, I can't, like, equation 10, I can't find any interpretation that makes, like, sense. Like, just that one equation with 3 variables. I cannot get something that seems like it's... What could, like, Taxwell be if you take Nimbo as the base? What? Why does that help? What? If Nimbo is the base, then Taxwell is Taxwell, right? Like... What? It's literally any digit, right? Am I crazy? That, like, if Nimbo is the base and you take mod the base, you don't get anything. Am I stupid? What? Oh, okay. I mean, oh, I see what you, okay. You're saying I should really believe this is the base and then write 3 here and then pray. Fine. Okay. Okay, so like 3 times 30... Or like 3 times 3b plus something is... I don't know. Seems sus. What bases are like not awful? Like if Taxwell is 5, I get 105 minus 30. It's like, I don't know. That doesn't seem good. Anything that resembles base 10, we concluded that mod 10 it doesn't work, right? Like YT is T mod 10. Wait, I don't know. YT is T mod 10 is Y minus 1. Yeah. So if it was like some relative of base 10, Taxwell has to be 5. Maybe it's like base 20? Or like some fake... Like, I guess this has to be 5 for this to even remotely make sense, but then I don't know what the base is. Like... It's like 3 times 3b plus 5, 9b plus 50, and then 3b plus 5, and then 6b plus 10. I'm really getting dragged through this kicking and screaming. Like, maybe, like, if we work in base 40, like, if I make the base 40, then the numbers are, like, remotely humane? Then this is saying, like, 405 minus 125. No, that's awful. That's the infetti is like 280. Hang on. What was it? So 3 times 3b plus 5, wherever the base is like whatever this capital F is plus 3b plus 5. And I want to like find a base that seems like reasonable. And it's like 6b plus 10. So it's always like 9b plus 6b plus 10. Wait, isn't 40 good? Like theta can be like like if this is 40. Yeah, why did I think this is bad? 375. Yeah, then this can be like 250. Alright, and then theta times this can be like 10,000. Okay. I don't know. This seems really desperate. I really should use this in a different color. Actually no, it's fine. So like here, 40 question mark with like many question marks. At which point I still don't know what. Like, okay, sure. 5. But then what does Yamparo Fete mean? Yeah, like if Fete is 250, then what the hell is Yamparo Fete? Is that like 500? That doesn't seem right. Yeah, no, this feels awful. I hate this. Like even if I know Yanoue is 3, like the reason I wasn't doing it earlier because I was like, even if I know the value of Yanoue, I cannot get any values of Taxuo and Fete that seem to make sense for any base. So what? 250 was really bad. Can I not make this work? Yeah, and then Yanporo to Roomba becomes enormous under this interval. I feel like Fete should be like a digit, but I can't get a digit that makes sense. So 3 times 3b plus 5. 3 times 3b plus 5 is like, I want it to be something. Okay, I don't think I believe this is 5. No, go away, go away, go away, go away. So like, okay, so we think it's like 3b plus Taxfo is supposed to be theta b squared plus 3b plus Taxuo. So I'm looking for a nice integer solution to 6b equals fb squared minus 2t. Where f and b are like digits, and t or f and t are digits, and sorry, 6b plus 2t. And I don't know. Does base 6 happen? Are there bonds that use base 6? Not. We'll try no. Great, so we can try the. Yeah. What? I just like there's. If Nimbo is the base, then like it has to be this, right? But I just don't see any integer solutions that make any sense. Like I'm not crazy, right? Like if you believe Nimbo is the base, then are these equations not true? Equations, yeah, okay, so like what the fuck is the integer solution to this? I can take mod b. I know, so b like b divides 2t. That doesn't like I'm trying to take t equals 5, which would force b equals 10 because b has to be greater than t. But that doesn't work, right? Like just 60 plus. Like the problem is b divides 2t, so particular b is at most 2t, and then I guess 14b. I don't know. Yeah, like it's just I just can't get a solution that looks reasonable. Like it's supposed to be the guessable solution, I'm assuming, but I can't guess it. 30, 36, 6, 6, 6. No, 6 is not actually a digit, so I guess it could be a base 5. Hang on. Sorry, 6 is not a digit. A digit is 3, so 30, 20. But then t doesn't. No, b has to be even because b divides 2t and is greater than t. In fact, yeah, actually b has to be like exactly 2t, right? For this to be plausible. Is my number theory? Am I a stupid head? So it's like 14. Yeah, this is what I was complaining about though. Like, now there's a 7 involved, and that's not a good sign. Like 7 equals f times 2t. Seems really bad. I don't think that has good integer solutions. Yeah, so like it's like it's if it's a base, then b divides 2t. T is actually a digit. So b equals 2t. Yeah, but am I stupid? If b equals 2t, then 12. You get 14t equals f times 2t all squared. So 7 equals f times 2t, which is like not good, right? Equation 9 gives you. Oh, I'm still looking at equation 10. 2t equals f, or 2t equals f plus b. I wasn't even looking at that one. I was still staring at that. Okay, what happens here? 2b plus t equals 2t plus f. Oh my god. Okay, no. This button. Yeah, okay, that's right. Yeah, like I just don't see the integer solution. And you're telling me like you just like I don't know, like even if I put in 3 for it's just it's not. There's no base system for which it's actually. Let me. I'm gonna write some more Python to make sure. Hi Python. We'll try all the bases between 1 and 100. All right. Oh sorry. It has to be at least base 5 or 4. Here. Oh, is 0 a digit? I guess 0 could be a digit. I'm just gonna brute force this. I'm so pissed right now. That's gonna be it, right? Wait, actually, oh, this one time might take a while. I guess it is searching a billion things. A billion? A billion. Okay, anyways. 160, maybe? So, base 6, b equals 1, t equals 0. I hate it. Okay, let's try it. We're gonna put 6 as the base because I don't. Literally, the others have repeats. So we're gonna make the base 6 because why wouldn't we? And then, what do we agree? F is. If so, F is 1 and T is 0. Yeah. Actually, that's not too unreasonable, I guess. Okay, so then Fete is 1, 13, and then it's like... Okay, this is like 0. No, what? That doesn't work. Like, Fete SR taxable better not be 1. That's like the longest... Ugh. Yeah, actually, if this is a base system, equation 9 doesn't make any sense because, like, the sum of a 2-digit number and a 3-digit number is never a 2-digit number. So, unless Yamparo Feti might be specifically like 36. Like, I guess it works if you do like 4, 0, and then this is like... We're just gonna write 36 for Fete everywhere, alright? It's like Fete is 6 squared. And then I guess it kind of makes sense. I hate it. This doesn't feel very consistent with anything. Anyways, so if so, then like 2 Fete is Tarumba is like 72. I think... Your equations are... Oh god. Can I just like... give up? Like, I don't... Beta is actually 36. No, even Nimo equals... Oh, Nimbo equals... Wait. No, Fete is 36. Wait, I'm so confused. In 11. Oh, sorry. Nimbo is 6. No. Yeah, Nimbo is 6. I'm looking at the wrong annotation. The 2 is labeling Yaparo. So this is 216. So okay, I guess like fun. So like Fete is and Tarumba. Let me color these differently. Are like the places or something. I guess to some extent Nimbo as well. Like I don't know. Like you say Yamparo Fete the way you say 200. Nimbo. Okay, anyways, so Asar is 4 now. Asar is 4. And Tamboroi, we have no idea what it is. But we haven't used... So we're working at base 6. What would Tamboroi be? I'm just gonna write 36 for Fete. Like, I really wanted it to be like 1 plus 4 is 5, but we already, like, so the digits are, the known digits are 2, 3, 4, 5, this is Yamparo, Tax, Wall, and, sorry, I don't know why I have 5 written here. Wait, sorry, 5, I need to be better at annotating these. 5 is left over from before. We agreed this is actually 0. So, we're just gonna put 1 and 5 here, because that way we get all the digits. And then we'll put Nagambi here. And Asar is known for, that's fine. I guess we might not have a 3. No, 3 is Yano. So we'll put tempo right here. Alright. Alright, awesome. So this is Tarumba, which is 216. The digit 5. Fete, which it means 100. Okay. And then Asar, which means 4. So in base 10, this is the number, I don't know what it is. We'll compute it later, alright. No, it's 250. Okay, that's pretty good actually. And then where Meek makes no sense to me, so we're not gonna touch that. And Nadamno doesn't either. But Sen Tantoli is 250, and this is 432. Yamparo Tarumba. Yeah. Yeah, so Fete, I see. So Fete is not a digit, that's the problem. Not in... There, it is kind of... It means 100 is what is going on, I think. Wait, I'm confused. How did I get here? Yeah, the problem is that this is a lie. It's not actually. Fete just means 100, or rather. Oh shit! Did I fuck up? Shit. I'm bad at basics. I'm sorry. Yeah, sorry. You're right. It's 400. Uh. 400. Okay, so this is 400 and this is 432. So that means this is 400. And on, I'm assuming, means plus? Maybe? So sem, and then sen. Or maybe ken. I don't know if it's a hard C or a soft C. I don't know, man. It's possible like on is plus and then is minus, or something like that. I'm not sure. Okay, anyways, back to here. So now that we know sen tensoli is this is fake news. It should be like f is b squared. Yeah, so when you told me the equations were true, true is a very generous way of putting it. Anyways, okay. Okay, so anyways, at least 400 makes sense. Like, since it's only being 400, seems to suggest that this is like a kind of base 2 thing. Or, sorry, something that will have something to do with the prime 5. And... se... I didn't know how to say it. I don't know. I think it's just false. Like, the equation assumes that feta is a digit, that's just not correct. The point is Nimbo is a base and feta is a base and Torumba is a base. And then everything's fine. Yeah, I really want like on to be plus and then to be minus. But I don't know. Can I just... Like this, the things with the C's seem to be vaguely be digits. Or is it on is... No, it should go... It should be like plus minus minus, right? If I want to believe the... Hmm. Math, not No, actually, might actually just be plus as well. Somehow, like if you look, equation one looks like it's saying like x plus one times x is like x, and then presumably the other. I don't know if say is exactly one. It might be. Actually, yeah, that doesn't make sense. If I it's 400. So like 432. If I want to break it into four things, is like 2552. Wait, actually on. Let's just write shit down and see what happens. 2552 sounds like. No, but I want Poholi to have. Does Maldalti ever have a coefficient? Like it could be like, I don't know, like 4, 100, 5, 2, and then like no, that doesn't work. Like it could be like 20 and 10 or something. I'm not sure. Or it could be one of those shitty things where it goes minus. That I may never know. How did you figure out the Aramba part? Extreme trial and error. By which I mean I ran this fucking program and then decided that t had to be 0 for anything to even remotely make sense. And then figured out that I was being duped. Yeah, but it's base 6. This was going on. Okay, actually, let me do the I'm gonna look at 16 quickly. So, because we know all the other shit, right? Like this is Nimbo is this 6. This is like 216. And I have no idea what Wearman key is, but if we believe that it's we want it to be like a big number, right? And also 224. We want some large power of 6 that is, yeah, 7776 I think works here. If we believe this is all going to be basics magic, this is 8,000, and 8,000 is sen sequibly, whatever the hell that means. So is Tuxwo? I think Tuxwo. Oh, it could be a 6 marker, or actually I don't know. Yeah, okay, I think it's definitely 8,000. So it's possible this is a base 20 and then Sen is 1. I think I would totally believe that. Because we got Sen Sonly and Sen Sequiply. Thank you 3VT for 20 months. Yeah, 8,000. This is Sen Sonly. Yeah, I feel like if 408,000 have special words, it should be like some form of base 20. But then I don't know what... We did not attempt IMO 6 because, I don't know. I kind of want to be able to sleep tonight. Yeah, Taxwell might be a... Do you think the Gombi Taxwell would get abbreviated to... Nimbo? Is that a thing that can happen? Yeah, because it is strange that they have like Yonparo Fete and Fete, but like Nagombi, Taxwo, and then Nimbo. It's possible that Nimbo is just okay. So Nimbo is short for Nagombi Taxwo. Fine. Anyways, as for no, Sam totally Sam. Wait, Sam and well, that has two dots above it, so who knows? But like if I think Paholi is a place, and it probably is based on the 432, then Sem is like times 2. Or Sam times equals, like I should be able to divide out the Paholi, I think, maybe. I could get 13. Nadomno? Wait, how do I get 13? I don't have any information on the right hand side. Wait, what? Do I think it's 1296 or something? Okay, fine. Maybe it's just 1296. In which case... I have no idea. Like if I think this is 1296, in line with the powers of 3 6 garbage. I really want Sen and Sem to be like 1. And then this can be like... Yeah, okay, what if I gloss... This is 1, and then this is like 3, 400, and then... one of something, and then... Oh my god, I have no idea. Make a very educated guess. I mean, I think it's base 20. I don't know. But it's too long, isn't it? Like... Okay, I think I don't believe the minuses anymore. I think I just want this to be like... I want this to be 2, and I want the other shit to be 30. like 20, 10. But I mean, it's definitely base 20. I just don't know what to. $12 and like enough to what is on that doesn't quite work the way I wanted to. On totally on se. I have a bunch of numbers now. Do I mean do I believe those numbers? Like guessing extremely overpowered. Unholy. I just can't tell the difference between and on. Like I don't know why there's two of them. But also, I can't tell the difference between Sem and Sen either. Like, they both just look like one to me. Maybe I'll find out. We'll find out. Okay, it doesn't tell me anything about, actually. Is like 10 or something? No, but I thought my calorie was 10. Yeah. Polohai on Chikom, which is something else. Makole. So like 60 plus 10 plus something is like. I feel like something's wrong. This doesn't feel very good. Like somehow on totally on se has to be 16. It doesn't feel like a good 16. Like unless like Hextoli is 15 and se is 1. I feel like everything that starts with like CE has become 1. Like, do I think this is 15 and this is 1? And this is 15 and this is like I feel like I'm just pulling stuff out of the air. Yeah, I don't know, man. Actually, so if we're working at base 20, it would make sense for like 5, 10, 15 to all have their own words, and then it's like a 20, a 10, a 2, and then 20. Like within each digit, you then split it up based on 5s or something awful like that. Everything's good. God, I hate this. It's just like, you know, just make stuff up and pray. McCooley, so sen yeah, no, sen So like 10, 3, 39 is there's gonna be like a20, and then like Caxtole is 15, so Nahue is the 4. That actually matches the 4 from before. I feel like there's a bunch of things inflecting and I can't tell why. 60 Nahue, no. Okay, so we just think the no stuff is 4. Polowe is 20, and then Se is 1. So it's like 81 is equal to 14 plus 60. Chicom is... Wait, did I finally die? Chicom is 7, and then Chicom is 7, 2. The is 2. Okay, well, it's okay. I think these are the equations. And then I need to actually finish the task. So Aramba is straight base 6, so I should be able to just do it. By which I mean we're gonna just write let me move this chunk down. Okay, so for the Aramba, let's do some arithmetic, okay? So 43 is 36, 6, 1 in base 6. So this is Fete, and then whatever base, Fete, Nimbo, Nagambi. Go up. And 569 is 432 plus shit, arithmetic is hard. 108 plus, oh, how very cute, it's 2, 3, 4, 5 base 6, which is Ion Paro, Tarumba, Yanoe, Fete, Asar, Taxwell, and then 5, which is Tambaroi. Okay, and then as for Aram, for Nahoto, so now I have to like actually pray because I feel like there's so much inflection I can't get the exact strings without But 42 is probably, it's po, hua, li. And then I need to add 2 somehow. And are there any examples where they added 2 in 432? Me. And 494 is like... Okay, so we're gonna steal the sen to zontli. And then I need like a ton of... Okay, so on... No... Po... Huali? That's okay, and then I need to add 14 somehow. So we're just gonna write mathtosti and then on Nahui. Or something like that. I don't know. Okay, like just something. Okay, I've decided it's good enough. Oh, Nimbo is actually 6. Like, they just have a digit for 6. Alright. Oh, okay. So the on versus on is just okay. And they just also have a hard-coded 7. Se. Sen, se. And they just dropped the... Okay. Namely, on is... The write-up has some... small details, yeah. Okay. Alright, we're done. Yeah, that happened. It's like past midnight here now, so... Wow. So, like... It actually was just base 6. So what did I learn from this? A certain type of yams grow and they grow a lot of yams. I mean, I think base 6 has nicer math properties than base 10 by like a lot. Like 2 and 3 are good, and then 5 is sum of digits and 7 is alternating sum of digits. So like all 4 small primes behave really well in base 6. So like base 10 where like 7 is a cluster. Yeah, I think the conclusion is I should just guess more. Was I supposed to... I don't know how I was supposed to come to the basics conclusion. I think I should have concluded t equals 0 after some analysis. Yeah, okay, yeah, I should have. I think I just didn't think about t being 0. In which case, it is, the equation is like 6b equals fb squared, like, yeah. You are entitled to divide into base words and units words. I mean, I don't know, just by frequency, like I should assume Taxmo is a base because it shows up so often, or what? Like, cause Fete looks like a digit, right? Because there's Yamparo Fete. I guess it's not a digit because in equation 9, if everything is a digit, then like the sizes don't match. So Fete has to be a multiplier. Okay. Fine. I don't know. I see. Okay, so because it's a shorter result, I should expect it to. Okay. Well, that happened. Okay, fine. I see. I should. Okay. I don't know. Honestly, given that I know Chinese, I shouldn't be surprised. But also, like, ugh. What's the opinions on the ILL? Ichensu. Oh my god. I read the first 3 characters and immediately knew what the others were. I don't know. In the sound X, at least sort them like alpha or okay, whatever. Like, why would you put them in arbitrary order? You can sort them with the blanks coming. Okay, anyways. Lewis and Little Jones. Alloway, Anderson, Ashcombe, Buckingham. I don't know. Like I see the, I just I guess you just have to adapt. I feel like, you know, I'm trained from a math background, so like I'm less willing to like make an assumption and see if it works. Well, okay, like a math slash puzzle hunt background. Because also in puzzles, like in puzzle hunt puzzles, like if you're doing the right step, you like immediately feel it's right. And here I'm like, I don't know, trying to solve a fucking Diophantine and being like, doesn't seem to do what I want. So SoundX is a compression, right? Like it's not like you can, given a SoundX thing, uniquely reconstruct. Anderson Allah. Yeah. E.g. how, yeah. I guess if you see a lot of examples of number systems, you'll be more willing to like make random guesses. I don't know. I think the last time I did a number system, it had like pluses and minuses. I was just like, oh crap. Basics. Alloway is definitely the 400, right? Ashcombe, maybe? I'm not sure actually. Stanmore and I don't know, man. Yeah. Okay, anyways, alright. So we did IMC, IMO, and the linguistics problem. How long did the wait? Actually, how long did we spend on this crap? Oh, okay, actually only an hour. I guess the IMO problem took like long geo. Oh my god. If the geo's actually hard, I don't want to start it at midnight. Like, is anything on here easy and will like I can solve before I fall asleep? Show problems again. Actually, I'm scared. The G1 starts with the pentagon, so I don't know if it's. Schweitzer looks interesting. Yeah. Yeah. Okay, I'm gonna try the G1, and if we're not done in like 40 minutes, I'm just gonna go sleep. NT main is a very generous description of my knowledge of number theory. Dude, honestly, like I was saying earlier today, I feel like, okay, sorry, this is a digression. Okay, but Imagine you have like you're like teaching some kid like number theory or something, and they're like you're trying to like explain to them what quadratic reciprocity is and how to use it, and the kid just asks you like, "What is it true that if a is b mod p, then a squared is b squared mod p?" Like when you hear this, you should just realize that like they're way over their head. Like if they don't know that you can square both sides of mod p, they shouldn't be trying to learn quadratic reciprocity. And this is how I feel when I'm like trying to learn number theory. Oh, it's just like wow, like you know, I'm trying to take the what was it? Cartan decomposition of S3 of like the symmetric space on GL3F where like F is extension of a local field or something, and I'm just like, dude, what's a local field? I don't remember. Is that the same as a DVR? So is this an attack on someone? Yeah, it's an attack on me. This is how I feel when I'm trying to learn math these days. Oh, like nothing makes any sense because I don't know. I don't know that I just don't know my stuff. Okay, it's really bad. All right, so regular pentagon appears, and you have a point P on it. Oops. Okay, and then there's two circles. So we'll do G1 is circle PAE, and G2 equals circle PBC, and here's Q. And so Q is like that thing, and then R is supposed to be the circumcenter of DPQ. And I need it to move on a line. Okay, so first we're going to check the edge cases. Well, okay, that helps. How come? Oh, I see. Q is badly defined. I want it to be like Q is the reflection of P across the line through the centers of the G1 and G2, so that it doesn't break when I move it. And yeah, seems to move on a line. I agree. And that is the line through the center of the pentagon. Wow, yeah, this is a problem that having GeoGebra certainly helps. So I want to show that OR is parallel to AB. Is that the play? Okay. Let me draw the circumcircle of the pentagon actually. Oh yeah, sorry. I should put up the problem in a reasonable way. One moment. Okay, whatever. Okay. Wait, shit. How do I... Okay, there we go. No, it's showing the other side. Fuck! Okay, much better. Except it's too small. Okay, sorry. Yeah, so the problem statement is that you have a pentagon ABCDE, and then it's regular, and then you pick a random point P, Q, and then you want to show the circumcircle of DPQ, which I don't know. It's I guess a thing you can draw. Is supposed to move on a fixed line, but if you just look at the thing on GeoGebra, it's pretty obvious what the line is. Which is oh shit. What? What do you mean how G is defined? G. I use G. Okay, well, let's just use this. Yeah, basically you want the circumcenter of R to be on such that RO is parallel to AB. So So actually, it's a bit of a red herring, right? Like, really, you want to show that if M is the arc midpoint here. So, how do I draw the arc midpoint easily? We went over this. It's like the circumcenter of AB and the incenter of DAB, I guess. So it would be sufficient to, I think the blue circle is basically, the R is basically a red herring. And it's just like DPUM, you want to be cyclic as P varies, which means that I probably just draw a bunch of radical xi. And pray, maybe. I definitely extend line PQ and see where it goes, right? Because now there's like 3 circles through it. And then line DM. So in an ideal world, that point intersection won't move, but oh, it actually doesn't move. Wait, really? Yeah, okay. GeoGebra really makes this problem a lot easier, because the red herring is pretty bad red herring. So we're gonna let T be like. So T is this point, and then I feel like I'm not using the fact it's a regular pentagon. Something's wrong. It shouldn't. This is a little too clean. So we let T be like the intersection of like D, O, M, O, A, E, and C, B, and we want to show that PQ passes through T, which it does. Wait, what? Wait, what? Huh? Wait, no, it can't be this easy, right? Wait, no, is this a solution? Am I crazy? So PQ passes through T and we're just fine. Where did I use the fact that it was a pentagon? Like, just, like can E and C be random points or something? Wait, what? Like, I never use the pentagon as regular. Other than, like, the nice axis of symmetry. Hang on. Really? Can I? Okay, alright. Okay, alright. Well, we'll take it. We wanted a quick problem, we got one. I didn't expect it to be this quick, but, Uh... Alright, yeah, okay, let me write this up. I don't really want to use the GeoGebra diagram because I actually don't want to use the fact that pentagon is regular. So, because, like, we literally did, like, nothing. Shit, also wrong file extension. Alright, so M is, well, M is the South Pole, D is the North Pole, O is, oh, we don't really care. And then, like, I don't know. We can just pick, like, random points, right? We don't need the... If I'm correct that we just never used, yeah, like, this is, okay, whatever. I might eat crow shortly if it turned out I'm being stupid. B plus negative foot, T O B. Shit. Okay. Fuck. Have you seen the ISL? I have been sent the IS part. I've been sent 3 problems from the ISL to test off so far, and I haven't looked at them yet because I just don't have the time. Yeah, I don't know. It's really bad. Maybe I'm telling myself like over winter break I should actually like do the ISL, but I said that last year too, and it didn't happen. So it's bad. It's real bad. Right. So. Let's just do this. And Q will be the... Yeah, let's see if this actually does what I wanted it to. Oh shit, I don't need opacity on this. I think I want this picture to be like twice as big. How's the UCMO stuff? Going along well. So the UCMO was selected a long time ago. The test, we do test selection like way farther in advance than people think we do. So the problems have been chosen for a while now. It's just like, okay, I think I want to move P a little over. What did I miss? You missed linguistics and a geo problem that took like not very many minutes. Yeah, like the pentagon just doesn't need to be regular. Like even remotely, like it's just A and BC need to meet on. Oops. Why not just have it in the summer? Because people are all over the place in the summer. I don't know. Like, people will just be at camps or on vacation or whatever. I guess. I don't know. Maybe I'm just saying that because we ran it in the fall in the many past years, but summer does feel like an awkward time to just run things in general because people have things they do. Okay, I think that looks good. Alright, and let's write this up. For any it doesn't need to be, hang on, I don't think I even need M to be the self pole, right, for this argument. Let me verify that in here. Yeah, M doesn't even need to be the self pole, it can just be like whatever. It's literally just true for any cyclic pentagon that R lies on the perpendicular bisector of DM. I think, right? Because yeah, it's just and let dt meet the So claim dp, qm are cyclic. follows by radical axis. Since TA times T equals TB times TC. So okay, so since like this point lies on every radical axis under the sun, it follows T lies on the radical axis PQ. Since T P times TQ equals TM times TD. TM, which does not depend on the choice of P. And it's thus the desired fixed line. The end. That was the problem. Okay, I agree this problem is ELMO difficulty. Because I feel like ELMO keeps having this problem, this issue where like the problems end up being way too hard. And I think this one is safely not in the way too hard zone. But unfortunately, it's not like this problem got used anyways. Also, what the heck is that figure? Oh, there we go. Yeah, see, at least... I don't know, man. Yeah, this is actually really easy. You don't even... It's literally just power of a point. I don't know what else to say. What do I tag? I didn't angle chase either. It's literally just power of a point. Thank you, Happier I Want to Be, for the follow. We'll just leave it at that. It's almost shortlist out. I forget which Geo was actually on the ELMO. Just G8. Isn't it super late? Yeah. Is no one going to point out? Oh, P lying on AB also doesn't matter? Oh. That's funny, actually. I should make a note of that. That is a good point. Yeah, it's also just better. Alright. Cool, alright. Yeah, I think it's late enough I'm gonna sleep. I don't want to start... If I start a Schweitzer problem at 1 AM, it's just not gonna work anyway, so it's like, yeah. Alright, thanks everyone. The 8 people that are still here. We'll be back next week for one more regular stream before I go on an extended vacation. Haven't dropped a diamond. Okay, anyways. Wait, why? Like, I don't mind a few extraneous conditions, but this is a little over the top in terms of extraneous conditions. Literally, like, they had a regular pentagon and a point on a line, and you didn't need the pentagon to be regular, and you didn't need the point to lie on the line. So, anyways, alright. Good night, everyone.